Furthermore, we have sum of AP. Remember, we have done the formula for sum of n terms of an AP. Sn is n by 2 into 2a plus n minus 1 into d. This is one formula. And Sn could also be written as n by 2 into a plus the last term, which could be, we can say T1 plus Tn, a or a plus L, where L is the last term. So according to the situation, if you know the first term and the last term, we can use this formula. If you know only the first term and D, use this particular formula. So this formula shall be used further ahead. So sum of the terms of the series 10 plus 9 and 2 by 3 plus so and so. So we have 10 and this is going to be 10 and you have 9 and 2 by 3, which is going to be 27 plus 2, 29 by 3, and this one is going to be 28 by 3, and this one is going to be 9, and so on and so forth. So we have to check these series. So D is going to be, let's check whether it is an AP. D is going to be 29 by 3 minus 10, which will turn out to be 29 minus 30, that is minus 1 by 3, and 28 by 3 minus 29 by 3, that is T2 minus T1 is minus 1 by 3, T3 minus T2, is it also minus 1 by 3? Yes. And if you do 9 minus 28 by 3, that is also minus. So it is minus 1 by 3. So it is an AP where A is 10 and D is, it's going to be minus 1 by 3, not 1 by 3, because it is an AP where the terms are reducing by 1 by 3. So in a way, it is going to be an arithmetic regression, but we generalize and give the name. It's a progression with a negative common difference. So A is 10, D is minus 1 by 3. And all these on adding should give 155. That is Sn is 155. You need to find n. Now, whenever we have n, you're bound to get a quadratic equation. Let's see what we have. We have the formula Sn is equal to n by 2. And here we can use the formula a plus the last term because, we have Sn, we have 155. So we don't know what the last term is. So it's better to use 2a plus n minus 1 into d. So Sn in this case is 155 is equal to n by 2. A is 10, so 2 into 10, 20 plus n minus 1 into d, which is minus 1 by 3. You can cross multiply. This turns out to be 310 is equal to n into 20 minus 1 by 3n plus 1 by 3. Which will turn out to be 310 is going to be n. You can take LCM. You have 360 plus 1 minus 1. So it's going to be 60 plus 1 minus 1. So this gets cancelled. So it's going to be minus plus 1 minus n. Sorry, not plus 1. So it's going to be 60 plus 1 minus n. You can now cross multiply. You get 930 is equal to 61n minus n square, or n square minus 61n plus 930 is 0. So we need to solve this and find out. Now here we can use, since it's a quadratic equation, we need to use the which among these values will be valid to solve it. So we can find b square minus 4ac, which will turn out to be 61 square, which is 3721 and 4 into 930, which is minus 3721. B square minus 4ac is 1. So in that case, n is going to be minus b plus or minus root b square minus 4ac upon 2a, which will turn out to be 61 plus or minus root 1 by 2 into 1. So it's going to be 61 plus 1 by 2, that is 32 by 2, 31, 62 by 2, 31, or 61 minus 1, 60 by 2, 30. So n could be 30 or n could be 31. So we have n could be 30, n could be 31. Now both these values, you have n is 30 or n is 31. Both these values seem to satisfy. Suppose one of them turns out to be negative, we may need to discard them. So whenever you have a situation wherein the sum of the numbers has been given and all other values are known, the only value you need to find out is the number of terms you are bound to get a quadratic equation. In that case, we solve it this way and we get it. Since this is a slightly bigger number, we can use b square minus 4ac formula and you get n as 30 or n as 31. Both of these are valid answers. And on verifying by substitution, you get both of them valid answers as 155. And this normally happens whenever d is negative, you're bound to get two positive answers. If d is positive in such cases, you will get one positive and one negative. There is only one possibility of two sum of numbers being equal to a specific value. But whenever the common difference is negative, two sets of values can add up and give the same sum. This is something candidates should remember because both 30 and 31 are valid. And hence both of them are valid among these. Right. Furthermore, we have three numbers of an AP which we mentioned, a minus d and a plus 2. As a quick recap, 5 numbers of an AP can be taken as a minus 2d, a minus d, a plus d, a plus 2d. And suppose it is 7 numbers, it's going to be 7 numbers, it will be a minus 3d, a minus d, and so on and so forth up till a plus 3d. And suppose it is an even number of numbers, in that case the difference has to be maintained. Suppose we have 4 even numbers, 4 terms in AP. In that case we take it as a minus 3d. Next one would be 2d more than this, that is a minus d, further 2d more, a plus d, and a plus 3d. And suppose it is going to be 6 numbers, we start with a minus 5d, a minus 3d, a minus d, up till a plus 5d. So suppose we have this kind of a situation, as we have seen in the previous cases. When we take it this way, they normally say the sum of the numbers or some number is divided into 5 parts, so that when you add them, straight away we get the value of a. Right? So this is something we need to use again and again, often. Now here, based on this, we have situations here. Sum of 3 integers in AP is 15 and their product is 80. So there are 3 integers in an AP and their sum is 15. So we take them as a minus d, a plus d, and their sum happens to be 15. So straight away this gives you 3a is equal to 15. A would be 15 by 3, 5. And their product, that is 5 minus d into 5 into 5 plus d is equal to 80, which means 5 minus d into 5 plus d, which is 25 minus d square, is 80 by 5, that is 16. So in that case, d square would be 25 minus 16, which is 9. So d will turn out to be square root of 9, that is 3. If d is 3, so the first term could be a minus d, that is 5 minus 3, 2. A itself 5, and the last term could be 5 plus 3, a plus d, 8. We can even take it as 8, 5 and 2. Both would be valid, because if you take the square root, you get plus or minus. Because if you take it d as minus 3, you could even get it as 8. Even this is in arithmetic, in an arithmetic progression. So among these values, you have 2, 5 and 8, as well as 8, 5 and 2, both as valid answers. So we have two options, both 258 and 852. Both of them are valid, but a practical consideration is, in the exam, since it's an MCQ format, you need to choose only one. So in serial order, whatever features as the right. So for example, in this case, we have two answers that are valid. So in the exam, you'd rather consider this one rather than saying both C and D are valid, because you need to consider. So by default, the one which appears first, two correct answers, the one which appears first serial order wise is taken as by default as the right answer. So although we have 2, 5 and 8 and 8, 5, 2 as two answers, because we get two values of D, in your exam you tick mark 2, 5, 8 because it features first. Okay. Here we have, find the ninth term of the series root 2, 5 root 2, 9 root 2 and so on and so forth. So we have root 2, 5 root 2, 9 root 2 and so on and so forth. So this is an AP. We have to see 5 root 2 minus root 2 is 4 root 2, 9 root 2 minus 5 root 2 is 4 root 2. Yes, so D is turning out to be 4 root 2. A in any case is root 2. Now this is a slight deviation. We're going back to the previous type of question, so that when you're doing the same type of questions, you don't get, you tend to get slotted yourself. So let's quickly revise. So you have been asked to find T9. So what formula will we use? Tn, which would be A plus n minus 1 into D. Therefore T9 would be A, which is root 2 plus 9 minus 1 into D, which is going to be 4 root 2. So it's going to be root 2 plus 8 into 4 root 2, 32 root 2. So it will turn out to be 33 root 2. So T9, that is the ninth term in the series, is 33 root 2. And hence among these, this is the right answer. And undoubtedly, it tallies with what we have got. Okay. Now, here again, this is a miscellaneous kind of thing. Sum of n terms of an AP. So in short, Sn is 3n square plus 5n. The series is what? So series, if you want to find what the series is, we need to find A, we need to find D. We know that A as well as T1 both will be the same as S1. That is sum of the first terms. Okay. So in that case, S1 is going to be 3 into 1 square plus 5 into 1, which is 3 plus 5, 8. So the first term has to be A. So it has to be either this or this, definitely not this. Now, we need to find the second term also. Second term will be given by S2. S2, this is the first term, second term, third term. So S2 involves this plus this. From that, if you subtract this, you get the second term. So it's going to be S2 minus S1. Now, S2 is going to be 3 into 2 square, 3 plus 5 into 2. This is the second term. Minus the first term in any case is 8. So this will give you 4 3s are 12 plus 10, 22. 22 minus 18, which is going to be 14. That means T2, the second term is 14. So you start with 8, the second term is 14. So, and this tells that the common difference is 6. So the next term is going to be 20. 20 plus 6, 26. So the correct answer among these is 8, 14, 20 and 26. Now this is something, please remember, candidates, dear friends, that whenever the sum has been given, please do not mix this up with the nth term. It's told sum of n terms, which means Sn, and always Tn would be Sn minus Sn minus 1. That is, the nth term in terms of sum is nothing but sum up till the n terms minus sum until the previous number of terms. And thus we have found out T2. So we have 8 and 14. Once you get 8 and 14, mentally you can calculate that the common difference is 14 minus 8, 6. So keep on adding 6 to each term. So this is going to be the right answer. And we can rest assured that that is the right choice we have made. Okay, so what do we have here? The nth term of the series whose sum to n terms is 5n square plus 2n is so and so. That means you break up the question, nth term of the series whose sum to n terms is 5n square plus 2n is so and so. That means you have to find the nth term. Tn would be what? If Sn is 5n square plus 2n. So how do you find Tn? To find Tn, you need a plus n minus 1 into d. So there are two ways of doing it. One method is finding out S1. We know S1 is nothing, is going to be 5 into 1 square plus 2 into 1, that is 5 plus 2, 7. S2, which would mean the first term added to the second, is going to be 5 into 2 square plus 2 into 2, that is 5 4s are 20 plus 4, 24. So the first term is 7, which means that A is 7 and T2 is S2 minus S1, which is 24 minus 7, 17. So T2 is 17. So that means it's going to be 7, 17 and so on and so forth. Which means that D is 17 minus 7, that is 10. So thus we have found out T2, which is S2 minus S1, that is the second term, and the first term in any case is 7 because S1 and T1 are one and the same. So D is 10 and A in any case is 7. So A is 7, D is 10, Tn would be A plus n minus 1 into D, which would be 7 plus n minus 1 into 10, which is 7 plus 10n minus 10, which will turn out to be 10n minus 3. Therefore, the nth term is 10n minus 3. So this is going to be the nth term if we know what S2 is. So among these, this is our right option. And yes, we do have that. Let's see what we have here. The first term of an AP is 14 and the sum of the first 5 terms and the first 10 terms are equal in magnitude but opposite in sign. The third term of the AP is so and so. So you have the first term is 14. Sum of the first 5 terms and the first 10 terms are equal in magnitude but opposite in sign. So if you see the sum of the first 5 terms, that is, and the sum of the first 10 terms, that is S10 would be equal to minus of S5. So S10 is equal to minus of S5 and but opposite in sign, or S5 is minus of S10. So and A is 14. So let's substitute the values. You have n by 2 So the Sn formula, of course, is n by 2 into 2a plus n minus 1 into d. So S10, which is going to be n over here, you put as 10 by 2 into 2a, that is 2 into 14 plus 10 minus 1, that is 9d, is equal to minus S5, that is minus 5 by 2 into 2a again, 2 into 14 plus 5 minus 1, that is 4d. This of course gets cancelled, and we can have now, hence as a result, even you divide both sides by 5, this gets 2. So you get 2 times 28 plus 9d is equal to minus 28 minus 4d. This gives you 56 plus 18d is equal to minus 28 minus 4d, giving you 56 minus 28 plus 28, I'm sorry, is equal to 18 plus 4, 22d, rather minus 22d. So d will turn out to be 84 upon minus 22, 84 upon minus 22, this will turn out to be minus 42 upon 11. So you get minus 42 upon 11 is d. Now you have been asked to find the third term. The third term, that is T3, would be a plus 3 minus 1, that is 2d, which will work out to be 14 plus 2 into minus 42 by 11. And that will turn out to be 154 minus 84 by 11, which will turn out to be 70 by 11, which is 11, 6 and 4 by 11. So that means T3 will turn out to be 6 and 4 by 11. So the first term of an AP is 14. The sum of the first 5 terms, that is minus S5, is equal to S10, equal in magnitude. Substitute the value, simplify it, and you end up getting the value of D as minus 42 by 11. Now that we know A, we know D. T3 is going to A plus 2D, which will turn out to be 70 by 11. That is 6 and 4 by 11. So among these, 6 and 4 by 11 is the right option that we have. And yes, undoubtedly, that's what is tallying with what we have got. So this is one type of a sum wherein you are satisfying certain condition. Again, there is only one unknown, that is D. A is already known, and with that we find the third term. Further ahead, we have a situation like this. The pth term of an AP is 3p minus 1 by 6, which means that Tp is going to be 3p minus 1 upon 6. The sum of the first n terms of the AP is what? So, the pth term of the AP is 3p minus 1 upon 6. So, obviously, you're going to have Tn will also be equal to 3n minus 1 upon 6. So, Tn is going to be 3n minus 1 upon 6. So, which means that you can say T1 is going to be 3 into 1 minus 1 by 6, that is 3 minus 1, 2 by 6, 1 by 3. And T2 would be equal to 3 into 2 minus 1 by 6, that is 3 to the 6 minus 1, 5 by 6. And once you know T1 and T2, T1 is nothing but A, and D is going to be T2 minus T1. You know the first term, you know the second term. It is T2 minus T1, which is going to be 5 by 6 minus 1 by 3, which is going to be 3 by 6, which is half. So 6 by 3, 3 by 6, half. So we have A as 1 by 3 and D is going to be half. And you have been asked to find Sn. Sn we know is n by 2 into 2a plus n minus 1 into d. Hence, this if you simplify, you get it as n by 2 2a is 2 by 3 plus n minus 1 into d, which is half. We need to simplify this, which will turn out to be n by 2 into 2 by 3 plus 2n, n minus 1 upon 2, not 2n, it's n minus 1 upon 2. You can take the LCM, n by 2, LCM is 6, so 4 plus 3n minus 3 by 6, which is 2 into 6, 12, n by 12 into 3n plus 1. So that means Sn turns out to be n by 12 into 3n plus 1. So what we have basically done is, as in case of finding Tn, you need to know A and D so that we can evolve a general formula of Tn in terms of n. Much the same way, finding Sn, you need A and D, or A and the last term. So we cannot find the last term because that is going to be Tn. So once you found out A as 1 by 3, D we find it out as half because we find T1 and T2, because if Pth term is 3p minus 1 by 6, nth term is going to be 3n minus 1 by 6. Once you know T2 and T1, we can find the common difference, that is D. And once you know A and D, we can use substitute in the formula for Sn, and you get n by 12 into 3n plus 1. So the correct option is 3n plus 1 into n by 12. Do we have it over here? Yes, this is what we have, n by 12 into 3n plus 1, which is our right option. And yes, it does tally with what we have got. So that's how we can solve these. We did cases wherein Sn was known and we had to find out Tn. Now we took up a case wherein Tn is known, and hence from that we find out Sn. Further ahead, we have is sum of an AP. You need to read these kind of questions very careful. Sum of an AP whose first term is minus 4 and last term is 146 is 7171. Find the value of n. So in other words, A is known to be minus 4. Last term, that is L, is 146. And Sn is 7171. You need to find n. Now here, which formula do we use? Not 2a plus n minus 1 into d. You can use that, but that will be a roundabout way of going about. Here, instead, we can use Sn is equal to n by 2 into a plus the last term, which will turn out to be 7171 is equal to n by 2 into a minus 4 plus 146, which will turn out to be 7171. So you have 200. 14342 is equal to 146, 142, and n turns out to be 14342 upon 142, which is 101. So n will turn out to be 101. That means 101 terms would add up and give 7171 when the AP's first term is minus 4 and the last term is 146. So 101 is our right option, and yes, it is 101. Now let's check what we have in store further. Okay. Sum of n terms of an AP is 3n square minus n, and its common difference is 6. Then its first term is what we have done. We have Sn has been given as 3n square minus n, and d has been given as 6. Its first term is asked. Now, we don't even have to bother about it. The first term is going to be S1 itself, which is going to be 3 into 1 square minus 1, that is 3 minus 1, 2. In fact, this D is a redundant term. If they ask you the first term and the second term, then yes, the first term is 2 and the second term is 2 plus 6, 8. So it's 3 into 1 square minus 1. T1 or A all mean the same, is the same as sum of the first term, which is 2. So our option is 2. Right, and we have got it right. Further ahead. Okay. Sum of n terms of an arithmetic progression is 2n squared plus n. What is the difference of its 10th and first term? So, difference of its 10th and first term, how we have to find out? Now, Sn has been given as 2n squared plus n. So, S1 is going to be 2 into 1 squared plus 1, 2 plus 1, 3. And we need to know, so this is going to be A. S2 is going to be 2 into 2 square plus 2, that is 4 2s are 8 plus 2, 10. And we know T2 is going to be S2 minus S1, which is 10 minus 3, which is 7. So the AP is going to be 3, 7. So from this itself, we can find that D is nothing but 7 minus 3, 4. So hence we have D as 4 and A is 3. So the 10th term, T10, is going to be Tn, we know, is A plus n minus 1 into D. So T10 is A, which is going to be, so we know Tn is A plus n minus 1 into D. We need to find out T10, which is going to be A, that is 3, plus n is 10, so 10 minus 1 into D. D turns out to be 4. So it's going to be 3 plus A plus 9 into 4, 36, which is 39. Now the question is not to find the 10th term, but to find the difference between the 10th and first term, that is T10 minus T1, which will be 39 minus 3, which is 36. Another way of doing it is the first term, T10 minus T1, is nothing but A plus 9B minus A, which will eventually be 9B, which is nothing but 9 into 4, 36. So you can even do it using the formula. So T10 minus T1 is 36. Either way you find T10 minus T1 is 36. So all these follow the same. There is a common thread finding out A and D, but you'll have to modify this to suit the requirement, specific requirement of the question. So T10 minus T1 is 36 and we do have it as 36.